Question 1. Glenn buys 4 tickets for a concert. Each ticket costs £54. Glenn also has to pay a booking fee. The booking fee is 5% of the total price of the tickets. Work out the total amount Glenn has to pay. So, he's buying 4 tickets at a cost of £54 each. So that's 4 times 54, which is £216. Now, the booking fee is 5% of the total price of the tickets, so we need to add 5% to that amount. Using the multiplier method, we do 216 times 1.05 to give that 5% increase. So 216 times 1.05 is £226.80. Okay, so we've got a method mark for the 4 times 54, and we've got a mark by carrying out the method to carry out a percentage increase of 5%, and then it's 3 marks, a mark for the final answer. Question 2. Tony has a hose pipe. The length of the hose pipe is 20 meters. Tony stores the hose pipe on a reel. The weight of the reel is 1.4 kilograms. Half meter of the hose pipe has a weight of 150 grams. Work out the total weight of the hose pipe and the reel. So it's going to be the weight of the reel, which is 1.4 kilograms, plus the weight of the hose. So if it's 20 meters of hose pipe and each half meter is 150 grams, each whole meter will be double that, because it'll be, instead of a half, it'll be a whole meter, so that'll be 300 grams. So if we've got 20 meters of 300 grams per meter, we just need to multiply those together. So 20 times 300 is 6,000 grams, which is the same as 6 kilograms. Now, adding our 1.4 kilograms and our 6 kilograms together, we get a total of 7.4 kilograms. We get 3 marks to this question. A method mark for finding what 1 meter is worth, a method mark for carrying out this multiplication, where we found that it would be 6 kilograms for the hose pipe, and then a method mark for adding the 1.4 and getting the final answer. Question 3. Describe fully the single transformation that maps shape P onto shape Q. So the transformation that turns this shape into this shape. I can already see by looking at this that it's some form of enlargement. So I'm going to put the construction lines of the enlargement in by joining up the same point on each shape and carrying on towards where I think the centre might be. There's that one. And I'll do it for I'll do it for the opposite corner, which is these 2 down here. And there we go. So, I can see quite easily that the centre of enlargement, where these 2 lines converge, is down here, at the point 0, 0. I can also see that this width of 3 becomes a width of 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a scale factor of times 3. So, in terms of describing fully the single transformation, it's an enlargement of centre O, which is the origin, with a scale factor of 3. So there's 3 marks for this answer. A mark for saying it's an enlargement, a mark for saying the centre of enlargement, which is the origin. I could have put 0, 0 for that as well, I'd have mean the same thing. And a scale factor of 3 gets the 3rd mark. Question 4. Tea bags are sold in 3 sizes of box. We have small 50 bag boxes, medium 80 bag box, and a large 125 bag box. And the prices are shown there. This information is just repeated here, but it asks which size box is best value for money. So we need to find the price in pounds per bag for each of these, and that allows us to compare them. So we'll start with a small bag. That will be small box. Sorry, that will be £2.15. The price divided by the number of bags, which is 50. And 2.15 divided by 50 is 0.043 pounds per bag. The medium is £3.29, that's the price, divided by the number of bags, divided by 80. 3.29 divided by 80 is 0.04, and I'm going to round it to 3 decimal places for comparison, so it's 1. Okay, and the large is £5.17 divided by 125. 5.17 divided by 125, which is 0.04136. Now I've just realised that these, I need to go to a bit more high level of accuracy to find out which is the cheapest between these two. So I'm going to write the full number for this one. 3.29 divided by 80. So it's 41125. Now we want the smallest price per bag. So this one's clearly this 0.043 is clearly bigger than these two, so it's not that one. Now comparing these two, the 0's the same, 0's the same, 4's the same, the 1's the same, but that one there is less than that 3, so it means this medium is cheapest, cheap per bag. So which size box is best value for money? Medium is best value. So in terms of marks, it's a 4-mark question. So I get a mark for each of these values and a mark for the final conclusion. Question 5. The diagram shows a tile. The tile is in the shape of a semicircle of radius 8 centimetres. Work out the perimeter of the tile. Give your answer correct to 1 decimal place. So, the distance across the bottom here is quite easy. That's if that's the radius, all the way across will be 16 because it would be the full distance. The radius is half the diameter. This curvy area around the top is more tricky. So what I'm going to do is find what would be the circumference of a whole circle and then halve it. So C equals pi d. So we'll take pi to be 3.142 times the diameter, which we just said was 16. Using the calculator, 3.142 times 16 gives me 50.272 centimetres. Probably don't need to be that accurate, but we want just the half of that. So I'm going to get my 50.272 and divide it by 2. we get 25.136. So I now need to add, that's this length here. I'll round it to 1 decimal place. That's 25.1 centimetres. Down there is 16 centimetres, so I'm going to add those together. 25.1 plus 16 gives 41.1 centimetres. In terms of marks, it was a 3-mark question. So a mark for getting the area of a whole full circle, a mark for dividing it by 2, and then a mark for adding it to the 16 and getting that 41.1. Question 6. Stephanie is X years old. Toby is twice as old as Stephanie. So Toby will be 2x in that case. Ulrika is 3 years younger than Toby. Oh, okay, so that would be 2x minus 3. The sum of all their ages is 52. Show that. Okay, so what we need to do is we'll add their ages together. So Stephanie is x, plus Toby, which we just said was 2x, plus Ulrika, which is 2x minus 3, and we know that they add up to 52. And now I'm just going to simplify that expression. X plus 2x is 3x, that's another 2x is 5x. So 5x minus 3 is 52. So I've shown, perhaps I should make it clearer by putting Stephanie, Toby, and Ulrika. I've shown that when you add their algebraic ages together, we get that expression. Then it asks us to work out the value of x. So I'm going to take this expression, 5x minus 3 equals 52, and I'm going to solve it. First of all, by adding 3 to both sides to get rid of that minus 3. So that leaves me with 5x equals 55, and then dividing by 5 to get rid of that 5. They cancel, just leave me with x is 55 divided by 5, which is 11. So with these questions, we get a mark for establishing these. So for the first one, we get a mark for establishing these bits of algebra. A mark for realising that they needed to be added together to get 52. A mark for correctly substituting them in and then simplifying. In terms of this one, this one's a 2-mark question. So we get a mark for adding 3. Or showing a consistent method could be the mark as well. So we get a mark for the add 3 and a mark for the final answer of 11, which would have been got by dividing by 5. Question 7. The diagram shows a container used to store oil. The container is the shape of a cylinder of radius 40 centimetres. You can see that here. The height of the oil is, okay, so that's just the oil, is 90 centimetres. 65 litres of oil are taken from the container. 1 litre is 1,000 centimetres cubed. Of course it is. Work out the new height of the oil in the container. So what we need to do is work out how much oil is already in that container, and we would do that by multiplying the base by the height. Now the base will be pi r squared times the height of 90. The radius is 40, so it's pi times 40 squared times 90. Now if we use a calculator to give that answer, I'm going to use 3.142 for pi. If you use the calculator's value of pi, you will get something slightly different, which is absolutely fine. Okay, so I get 452,448, and that is cubic centimetres. Now, we need to change that into, we could either change this into litres or we could convert this one into centimeters cubed, which might be easier. So that would be, if 65 litres, 1 litre is 1,000, it'd be 65,000 centimetres cubed of oil. So that's what's been taken away. So I'm going to now subtract that. I'm going to do 4, 5, 2, 4, 4, 8, take away 65,000. And that leaves me with 387,448 centimetres cubed. Now they want me to find the new height of the oil in the container, so I now need to work backwards. This is how much there is. I know what the base of the container is. So the volume of the tank will be pi r squared, pi times 40 squared, times by the height. But we know the volume is this. So I've got a situation, I've got 387,448 equals pi times 40 squared times h. So if I treat this like an equation and divide both sides by this, I'll put that in brackets. So I'm going to divide by pi times 40 squared. I end up with 387,448 divided by pi times 40 squared, and that's equal to h. And if I do that calculation, divide by 3.142 times by 40 squared, I get 77.0703, and it carries on. I want it to one decimal place, so I make that 77.1 centimetres. So any answer between 77 and 77.2 is accepted for this question. There's quite a lot of different ways to get the marks, but essentially this first piece here obtains a method mark. The subtraction gets another method mark. Then this rearrangement of the formula, or whichever way you've done it to work backwards, gets a method mark. And then the final answer gets your fourth mark there. Question 8, we have a trial and improvement question. They've told us the answers between 2 and 3. So I've created a little table, starting with 2.5, and I'm substituting it in. I get 30.625, which is too big, so I'm going to try a smaller value, about halfway between 2.5 and 2. So I've tried 2.5, and I found that was 2.3, and I found that was too small. So I'm going to try the bigger value. I'm going to try 2.4, which I found is too big. So I know it's somewhere between 2.3 and 2.4, because 2.3 was too small and 2.4 was too big. So to find out which it's going to round to, I'm going to try 2.35, and I found that that was too big, which means I must need to round it down. So I know the final answer to one decimal place is 2.3. In terms of marks, it's a 4-mark question. So you're getting a mark for each decision that you've made. So you get a mark for that first calculation, establishing it's too big. You then get a mark for your intermediate working. You get a mark for finalising on 2.35 and finding out that it's too big. And then a mark for correctly deciding that 2.3 is the right answer. Question 9. The scale on the map is 1 centimetre to represent 5 kilometres. Yanis wants to build a warehouse. The warehouse needs to be less than 10 kilometres from A. Well, if 1 centimetre is 5 kilometres, it'll be double that, which is 2 centimetres. And less than 20 kilometres, well, that'll be 4 centimetres. Show by shading where Yanis can build the warehouse. So I've used a pair of compasses to do these arcs. This arc here is the less than 10 kilometers away from A, which is 2 centimeters. And this one here is the 4 centimeter arc. And I want the area where they overlap because that's a suitable area, which is this sector here. Now it's a 3-mark question. You get a mark for determining the scales properly. You get a mark for correctly drawing the arcs, and then you get a mark for shading the right area. Question 10. Complete the values for y equals x squared minus 2x minus 1. I've done most of them for us already. 3 squared is 9. Take away 2 lots of 3, that's 6. So 9 take away 6 is 3. Take away 1 is 2. 0 squared is 0. Take away 2 lots of 0 is still 0. Take away 1 is minus 1. And minus 1 squared is 1. And then we've got to take away 2 lots of minus 1, which is minus 2. And then take away 1. So 2 minuses make a plus. So it's 1 plus 2, which is 3. Take away 1, which is 2. So now on the grid, we've got to draw a graph of this. I'm going to zoom out a little bit so you can see. So minus 2, 7, minus 2, 7 would be there. Minus 1, 2 would be there. 0, minus 1 would be here. 1 minus 2 is down here. 2 minus 1 is back up here. And 3, 2 is there. And we've got to draw an arc through these points. So as smoothly as I can. And back up there. Now, it says find estimates for the solutions of the equation x squared, which is this line we've just done, minus 2x minus 1 equals 0. So that's the places where it crosses the y-axis at 0, which is there and there. So I'm looking at about 2.4 and negative a half as my two solutions. So in terms of marking this, if you get all 3 answers, you get 2 marks. If you get just 2 of the answers, you get 1 mark. And if you just get 1 answer, you get no marks. But I got all 3, so I get 2 marks. And for the plotting the line, you get 1 for drawing the points correctly, and 1 for a correct curve. And then for this last part, you get a correct mark. You get a mark for each correct value that you've given. Question number 11. We've got a straight line that's been given with lots of coordinates along it. The coordinates of A are 9, 0, the coordinates of B are 7, 4, the coordinates of C are 1, Q, and they want us to find the value of Q. First of all, we need to find the gradient of that line, and we're going to use these 2 points in order to do it. To find the gradient of a line, M is the gradient, is the second y coordinate, take away the first y coordinate, over the second x coordinate, take away the first x coordinate. So the second y coordinate is 0, and then the first one is 4, so it's 0, take 4, over 9, take 7, which is minus 4 divided by 2, which is minus 2. So now we know in the equation y equals mx, well it's minus 2x plus c. So we haven't got the complete equation yet, but we're getting there. But we do know there's some coordinates 9, 0. So if we substitute those in, that's a value for x, and that's a value for y. So 0 for y is minus 2 times x, which is 9, plus c. So 0 equals minus 18 plus c. Well, c, if that's going to make 0, c is going to have to be 18. So c is 18. So I can rewrite my equation again. Instead of writing this I'm going to write y equals minus 2x plus 18. I'll put a box around that instead. Now, in order to find what they actually wanted, which was the value of q, they've got 1 comma q. That means x is 1 and they want to know what y is. So if x is 1, y will be minus 2 times 1 plus 18. Minus 2 times 1 is minus 2, plus 18 is 16. So the value of y, or actually it's q, is 16. Okay, it's a 3-mark question. 1 mark for establishing the gradient, 1 mark for establishing the intercept, and 1 mark for correct substitution and finding of that y value, which they lettered as q. Question 12. Solve the inequality 5e plus 3 is greater than e plus 12. So the first step with this is to try and get all the e's onto the same side. So I'm going to subtract an e from both sides to eliminate this e here. So 5e becomes 4e plus 3 is greater than, that e has disappeared because it's cancelled with that, so it's just left the 12. Next step, I want to get rid of the 3, so I subtract 3 from both sides. 4e is greater than 12 take away 3 is 9. And then to finish, I want to divide both sides by 4. Divide by 4, divide by 4. The 4's cancel. So e is greater than 9 over 4, which is the same as 2 wholes and 1/4. Part B, on the grid, shade the region defined by the region x plus y is greater than 1. First of all, we're going to plot the line x plus y equals 1. And in order to find out what that line is, I'm going to try some x and y values. So I'm going to pretend that x is 0. Well, if x is 0, y has to be 1 to make 1. And I'll try x being 1. If x is 1, y has to be 0 to make 1. So I've got some coordinates I can plot. 0, 1, which is here, and 1, 0, which is here. The next stage is to draw that line in, like so. Now, it's saying x plus y is greater than 1. So it must be at this side of the line. So I'm going to shade in this side here. So with these questions, you get, this one's a 2-mark question. So you get a mark for taking the e from both sides and a mark from subtracting the 3. And down here you get a mark for the correct plotting of this line, and then a mark for correctly identifying the correct region. Question 13. The diagram shows the positions of a tower and a tree. And they've shown this information is in this diagram here. So we've got a tower, which is 2.1 kilometers away from some point here, and a tree, which is 4.5 kilometers that way. And it happens to make a right-angled triangle, which is very convenient because we know how to use Pythagoras and basic trigonometry with right-angled triangles. So we need to work out the distance between the tower and the tree. So they want us to know this length here. Now, because at the moment there's no angles involved, we know this is naturally going to be a Pythagoras question. So to find the longest side, I'm going to get these two sides, 2.1 and 4.5. I'm going to square them and add them together and then find the square root of that answer. So, using the calculator, square root 2.1 squared plus 4.5 squared, and we get 4.9865. Now they've asked for it to 1 decimal place. I'm just going to write that that out as a string first of all. 4.96588, and it carries on. But if we want it correct to one decimal place, it means we're rounding it to just these two digits here. But 6 is a round up number, so that 9 is going to have to get one bigger, so it ends up rounding to 5.0. I'll put brackets 1 dp. Now, for part B, it wants us to give the bearing of the tree from the tower. So, in order to do that, I need to know what angle this here is. But there's no easy way to find that out, except that I could find this inside angle here first, and then take it away from 180 to get this one. And the reason why I can do that is because of trigonometry. So I'm going to use trigonometry based on this angle. This is the opposite, this is the hypotenuse, this is the adjacent. Now, I have actually just found out what the hypotenuse is, but in case I got that bit wrong, I'm not going to use the hypotenuse today. I'm just going to use the opposite and adjacent. So I'm going to write out SOHCAHTOA. SOHCAHTOA. And the one I want to use is the only one that's got opposite and adjacent in, which is the tan rule one here. So if we call this angle x, the tan of x will equal, and I'll just put this as a proper formula triangle, the opposite divided by the adjacent, O divided by A. So tan of x will be 4.5 divided by 2.1. But I don't want to know what the tan of x is, I want to know what x is. So I'm going to use the inverse tan rule. X will be the inverse tan of 4.5 divided by 2.1. And now we're going to use the calculator, making sure that it's in degrees mode. Shift tan, just as a fraction, 4.5 divided by 2.1. And close those brackets. 64.9 degrees. Now we're working to the nearest degree, so I'm going to make that 65 degrees. I'm going to round that answer. So now if I know that x is 65 degrees, to find this one here, I do, and this because this is angled in a straight line, I do 180, take away 65, and that's 115. So I know the bearing is going to be 115 degrees. So for this question, there are 3 marks for the Pythagoras. So a mark for recognising that I needed to use Pythagoras and producing this formula. A mark for correctly substituting in, and a mark for getting the final result. For the bearing question, it was 4 marks. So a mark for selecting the right formula, a mark for substituting in, a mark for the right answer, and a mark for taking it away from 180 to get the 115. Question 14. The value of a car depreciates, i.e. goes down in value, by 25% each year. At the end of 2013, the value of the car was £4,800. Work out the value of the car at the end of 2015. So that's a time difference of 2 years. Now if it depreciates by 25% each year, that means if you take 100% of the value and take away 25%, every year it's 75% of the value that it was, which means our multiplier would be 0.75. But this is happening over 2 years, so we need to apply this twice. So the value at the start was 4,800, and I'm going to times that by 0.75 to the power of 2, because it's over a course of 2 years. So 4,800 times 0.75 squared brings me to £2,700. So at the end of 2015, this was 2013, this is 2015, the value is £2,700. So for this question, it's 3 marks. You get a mark for recognising there's a multiplier, you get a mark for applying it twice, and you get a mark for a final correct answer. Question 15. D is directly proportional to x. D equals 36 when x equals 5. Work out the value of D when x equals 8. So, if D is directly proportional to x, that's the first thing I write. D is directly proportional to x. And that means that whenever you got something that's directly proportional, D would equal k, some sort of constant, times x. Now, we need to find out what the constant is, but the good news is that they've given us a pair of values which we know work. So D is 36 when the k constant is multiplied by x, which is 5. And to find out what the constant is, I divide both sides by 5. So 36 divided by 5 7.2 equals my constant. So now I know what the constant is, I can rewrite this formula. D equals 7.2 for the k, x. And that's my formula that I know works. So, when it says work out the value of D when x equals 8, I know that D will equal 7.2 times by x, which is 8. When I type that into the calculator, I get 57.6. So for this question, it was 2 marks. You get 1 mark for correctly deriving the formula, and a mark for substituting the result incorrectly. Question number 16. Write 4.5 times 10 to the 3 as an ordinary number. Well, if it's 10 to the minus 3, I know it's 0.00 because we're moving back 3 spaces. So the 4, which was before the decimal point, is going 1, 2, 3 spaces back, followed by the 5. So that is that as written as an ordinary number. That 4 has moved back 1, 2, 3 spaces, and so is the 5 as well. Now, for the second part, it says work out the value of 2.5 times 10 to the 2 divided by 3.8 times 10 to the 3. And this is sort of a kind of a cheap way of doing it, but you are allowed to use a calculator in this exam, and it's a question that lends itself perfectly to it. So I'm going to set this up as a big fraction, 2.5 times 10 to the minus 2 divided by 3.8 times 10 to the power of 3. So I have it like that. I press equals, press S to D, and it gives me as a rather unpleasant fraction there. So they want me to give the answer to correct to 3 significant figures. So I can see it's 0.0001 and then 2 more, 0, 0, 6, 5, 7, 9. So I need to correct 3 significant figures. So I could just put 6, 5. Now the 7's there, but it's rounded up because of the 8, so it becomes an 8. So that's it written as an ordinary number. But what I really want is it written in standard form. So it will be 6.58 because they're the digits, 658. But that 6 is going to be times 10 to the minus because it's very small. And that 6 is moved back 1, 2, 3, 4, 5, 6 places. Or I could cheat and just count the zeros. 1, 2, 3, 4, 5, 6. So it's 6.58 times 10 to the minus 6. So for these questions, the first one is just a 1 mark question for getting the correct answer. For this question, carrying out the division correctly gets you a mark, and then writing it in standard form is the second mark. Question 17. Paper clips are sold in small boxes and large boxes. We'll call small boxes of size S and large boxes of size L. That's how many paper clips they hold. There is a total of 115 paper clips in 4 small boxes and 5 large boxes. Oh, okay, so that means 1,115 is 4 small boxes plus 5 large boxes. And similarly, 530 is the same as 3 small and 2 large. Now they want us to work out the number of paper clips in the small box and large box, so we need to use simultaneous equations to find out what S and L are. So first of all, I need to get these so they have a common common term. I'm going to try and make the L's the same. So I'm going to get this first expression and times it by 2. I get the bottom expression and times it by 5. 5L times 2 is 10L, and 2L times 5 is also 10L, so that'll make them the same. So the first expression, 1,115 times 5 is 2,230. 4 times 2 is 8, so it's 8S, and 5L becomes 10L, which is what we wanted. And I'll call this equation A. And then picking up the other one, we're timesing this one by 5, so it becomes 2,650 is 15S plus 10L, and we'll call this equation B. So now I need to find the difference between the two equations, so I'm going to do equation B, take away equation A. And the difference between these two numbers is 420. 15S take away 8S is 7S, and 10L take away 10L, well, they cancel. So to finish off, I divide by 7, they cancel. 420 divided by 7 is 60, so I know 60 is S. So that's the size of a small box, but we need to find the size of a large box as well. So I'm going to substitute that back in to this first equation up here, which was, and I'll rewrite this down here so we can see it all together. 1,115 equals 4S plus 5L. So substituting in the S, 1,115 is 4 times 60 plus 5L. 4 times 60 is 240, so I can rewrite that as 1,115 is 240 plus 5L. But I want to get L on its own to find out what it is. So I'm going to subtract 240 from both sides. And that leaves me with 875 equals 5L. And then to finish off, I divide both sides by 5. So 875 divided by 5 is 175. 175 equals L. So I found the size of a small box is 60 and a large box is 175. 5 marks for this question, 1 mark for deriving the equations, 1 mark for manipulating the equations so they have a like term, 1 mark for getting this answer, 1 mark for the act of substitution to find out the other value, and a final mark for the other value, the size of the large box. Question 18. The diagram shows a solid wooden sphere. The mass of the radius of the sphere is 2 centimeters. The mass of the sphere is 45 grams. Wood will float in the Dead Sea only when the density of the wood is less than 1.24 grams per centimeter cubed. Will the wooden sphere float in the Dead Sea? Well, to find density, dmv, density is mass divided by volume. Now we need to know what the volume is. So from your formula sheet at the front of the paper, you can see that the volume of the sphere, here it is 4/3 pi r. So volume is 4/3 pi r cubed, which would be 4/3 times 3.142 for pi times 2 cubed. Now if you enter that into a calculator and round it to 1 decimal place, you get 33.5 centimeters cubed. Now, to work out the density, we get the mass and divide it by volume. We found the volume was 33.5 centimeters cubed, and the mass, it said in the question, was 45. So, divide 45 by 33.5 and we get 1.34 grams per centimetre cubed, which is more than this, and wood has to be less than that to float in the Dead Sea, so it won't float. And we could put because 1.34 grams per centimetre cubed is more than 1.24 grams per centimetre cubed. Question 19. OACB is a parallelogram. You can see it in the diagram. M is the midpoint of AC, although it doesn't look like it is on that diagram. It's not drawn, not accurately drawn. And C is the midpoint of the straight line BCX. So we've got to prove that OMX, so here to here to here, is a straight line. Now we can do that if we can prove that the vectors that take us from here to here, going through B, so OBCX, is the same as going O to there, but doing it twice. Because if it's the same as doing it twice, it means it's a straight line. So let's start off with vector OX. Now, treating this like road maps, it's the same as going across there, so that's B, and then going up here, which is parallel to that one, so that's another A, and because this is a midpoint, it's another A to get up to there, so B plus 2 A's. Okay, now if I need to find OM, OM will be the same as doing A, going up there, and then going across to here, which is, that's the midpoint of that line, which is half, because it's a parallelogram. The length of that vector is the same as the length of that vector. So it will be A to M will be a half B, or 0.5 B. So I'll put that on there. Now, if OMX is a straight line, doing 2 lots of O to M will be the same as OX. So doing this vector twice will be the same as doing this vector. And then that will prove that it's a straight line. So I'm going to do 2 lots of OM. So that's 2 times A plus 0.5B. And we're seeing if it equals OX, which is B plus 2A. 2 lots. So expanding these brackets, 2 lots of A is 2A. And 2 lots of 0.5B is B. And that does equal, that's the same. I'll just rearrange it so it's 2A plus B. So I write QED, that is proved. For this question it was 4 marks. A mark for deriving each of these expressions. A mark for realising that double one of them gave us the proof. And then a mark for your final conclusion, demonstrating that they're both the same. Jenny wants to cover a triangular field ABC with fertiliser. Here are the measurements Jerry takes. Angle ABC is 50 degrees. This is all shown on the diagram, but it does say here that they're correct to the nearest 5 metres. And they want us to find an upper bound for the area of the field. Now to find the area, because it's an angle and 2 sides, I'm using the area formula from the front of the formula book. You'll see that I've rewritten it, I've reassigned the letters so that, because the angle that we've got is labelled B, I've put the B there and I've put A and C here. With this formula, you only use A, B and C once, and the capital one's the angle. So because I put B there, I've had to shuffle it and switch B and C around. Anyway, to find the area, we do a half AC sine B, so that's a half times by A, which would be this side here because it's opposite that side, and this would be C because it's opposite that side. Now, it says 175, but I want the upper bound. Now, because it's been rounded to the nearest 5 metres, it could be anything as high as 177.5. And similarly, this one has been rounded to 225. It could have been 227.5. And then sine, and 50 degrees to the nearest degree could have been 50.5 rounded down. So I enter all that into the calculator. A half times 177.5 times 227.5 times sine 50.5, and I get a very large value. 1,579.5826, which is all fairly irrelevant because they're tiny numbers now in comparison to the magnitude of the number. Now, the answers accept anything in the range 15,500 up to 15,600, so that's acceptable to them. It was a 3-mark question. A mark for selecting the right formula, a mark for substitution, and a mark for the final answer. Question 21 is asked me to solve this equation. So I've got 4 minus 2x over x plus 1 equals x. So I'm going to times both sides by x plus 1. And that gives me 4 minus 2x equals x plus 1. Once I've done that, I'm going to expand those brackets. So 4 minus 2x equals x times x, which is x squared, plus x times 1, which is x. I'm now going to rearrange this equation by adding 2x and subtracting 4 from both sides. Add 2x, subtract 4. So 0 is x squared plus 3x minus 4. The next step is to factorise, because I've realised it's possible to factorise this expression, and that becomes x minus 1, x plus 4. So my solutions, x must be 1 and x must be minus 4. It's a 4-mark question. A mark for a rearrangement into a quadratic, a mark for each solution, and a mark for the factorisation.